All right, so let's take a couple of another look at this this item. We made the on-the-fly slide locator subassembly, and when I drug that in, I'm just going to right-click and open it. And when I drug that into the subassembly, I noticed that it did not retain the slot mate. And all the rest of the mates seem to have come over, so, coincident with all of those items did not have any issues. So I don't know what the issue with that one, but if that's the only one I lost, cool, I'll take it. Yeah, I'll count that as a win and go on. So we want to reapply the slot mate because it's still going to move within these dimensions. And I think we resolved the dimensions. It's another one of those. I sat and stared at it for a few minutes and got a slightly better view of what I suspect the rod is going to locate on. Basically, they're using the connecting rod without the lower half of the bearing in place. So that part of it sort of makes sense, is that this is contacting the inside of the connecting rod without the lower half. So to apply this, I need some portion of the slot, some portion of the hole, and we go into the mate. Is it going to jump right to it? Probably not. Tangency, maybe. Can't get to tangency. There's a gap tolerance there. There's not anything for it to pick up. So we're going to go over to mechanical. And then when I identify the slot, it's on the edge, or on the face, not the edge. And when I'm picking for any mates, just as a general statement of managing mates, faces and planes. So face to face, face to plane to plane. Those are going to be my first choice. And maybe not always my most convenient, but my most stable. All right, I'm always confident that I can get a plane to plane to work, or I can get a face to face to work. Then secondary is edges, and last is points. So in previous videos where we've started the assembly, doing two cubes at a point, they really orbit each other really nicely, but there is, other than that single point of reference, it is very confusing. We looked at the constraints, and this is going to be another one I'm going to have to open up the help file and say, okay, what is free do? Center and slot, distance along, or percentage along. So I kind of suspect that if we're some kind of cam or some kind of movement, we could set for the distance along or the percentage along to restrain the movement within that slot, because some other actuation is starting or stopping that movement. We're just using the clearance rather than going the full distance of the slot. So I'm always going to try 3 first, and if it cooperates, then I'm just going to stay with it moves from center to center, and that's pretty much all I needed to do. There may be another 10 or 15 thousandths of tolerance there, and I say that, and then I'm not sure if that's the case or not. So let's go to, and so my line, no, it's going to contact. So it's not even going to center line, it's going to contact. All right, I'm good with that. I mean, that's representing the movement. That is what I kind of expected to do. I can hit that wall, and I can hit that wall, and I'm done. And the spring that goes back here is the one that's providing the pressure, and and then that rough locator is probably the next thing that we're going to bring in. Notice too that wherever I position, wherever I position that whole two objects occupying the same space, it's on me. I have to make that determination. So this would be a good place for an angle mate. I know it can only come up so far, and I'm going to take my best guess and say 30 degrees. So while I'm in the mates, we've already applied, I hope. Yeah, it looks like. So a standard mate and an angle would say, set this at 30 degrees and you're done. 30 degrees, locked in, no movement. If we want this to be dynamic, we have to go to the advanced mates. And the advanced mates come into a limit angle, and it's not specifically called a limit angle, it's just the advanced mates angle. And you get 3 selections. All right, well, I didn't select anything, so my optional direction reference, plane, place, linear edge, or reference. Well, let's go with that one and that one. And I say it better not have separated from these, it's just the rotation. So first first angle is that it is at 30 degrees. That's its current location. The second maximum value, 30 degrees. That's its current location. If I set that maximum value to 60, fine, no problem. It's going to stay at 30 degrees, but it can move up here, and then it can only come down to 30 degrees because that's my minimum value. My minimum value goes to 0, and as long as my current position is between the maximum and the minimum, I don't have any issues. It's when I bump that number up or I bump that number down that it gets a little weird. All right, so I'm always going to try to go between these angles. I try not to do positive and negatives in my maxes and minimums. It has a tendency to get confused. Negatives, okay, the negatives confuse me, and then whatever it's doing confuses me even more. All right, so as we're moving these items around and other things are interacting, making this dynamic motion, there is a high probability that one of those plus minuses will reverse itself in calculating or resolving the current position, and that's usually a problem. And mate alignments kind of come into play there as well. So let's see what the result is of setting that. And I have my 2, so that one goes from 0, 30 degrees, 0, 30 degrees. Open, close. All right, so notice that I'm in the closed position. We save that. Let's go ahead and rebuild and save. And I come back to my top level assembly. It updates, and I go to open, close. Well, it moves back and forth because I haven't figured out where all that stuff goes yet. And but I can't open and close the cam just yet, or the cover and whatnot, because it's been set at a rigid as a rigid subassembly. So we look down through here, and I look for rigid, and I look for movable, and it would be nice, but I don't see it. So we come up to, sure, it's not going to be under component. Those are just view. Nope, don't want to do that. So for whatever reason, it's been in component properties forever, and it will probably continue to be in component properties forever. Is at the bottom right of component properties, we have solve as rigid, solve as flexible. As soon as I say flexible, well, I'm going to get the funky dance because everything can move, but I get the ability to turn. And then I find my 30 degrees. I was a little optimistic unless it's out here. And we're not going to make it out there more likely. All right, but that gives me the starting point. That gives me something else to work from, because I think there's still an issue when I set the dimensions that this face is still a little bit high. It needs to be closer than this face. But again, if I spent an extra hour nitpicking all of these details, I probably wouldn't be this far. It would be perfect, but I wouldn't be this far. So I'm counting on these iterations as we go through. We start bringing things in the assembly. I see something else, so I missed that, and I'm basically this is my safety net. As I'm putting this together and I'm visualizing how this goes together and going through each of these iterations as the assembly evolves, this is my chance to catch those, to think through the process again.
Run that by me again, because solve flexible and rigid is going to mean something different to me.
Okay. All right, so at this point, I made this flexible so it moves in the top level assembly.
Right. See, I would call that motion between rigid bodies. That's fine.
Oh,
so let's call that flexible. And then rigid, it's just basically calling I have one configuration.
Not even configurations. The last place that I left it in the subassembly, wherever that may
that's
be.
That's where it's going to consider it being fixed.
Right, so rigid. Okay. And now I go back to try and move it. Well, it can move side to side because that's the entire subassembly, because I haven't added a mate to tie it together.
Right.
So to return to the subassembly, and then I open that up a little bit. I save it, rebuild, do all that, come back in. Yes, go ahead and rebuild. Now it's in that position because that's where I left the subassembly. And so it's rigid based on the last known location in the subassembly. I go to move this, it's not going to move. And interferences? Yeah, I have interferences. All right, so if I want to look at those interferences, and this is as good a time as any to do
I'm going
it.
to ask you if you could turn something on that's going to show that or prevent that. And you're going to tell me yes, you can.
Well, the rigid flexible is one, and then once we get a number, once I determine what the max and min is of this locator drive, or I determine how much I can drop this face and get a little more clearance, then
make a pilot, assemblies,
yeah.
right? That's one of the things we're first concerned about is interferences, obviously.
Right.
Among other things later.
0.25. All right, so I still managed to. Oh, yeah, we still have to resolve that one. So I think I was being a little dyslexic on my numbers with that back, so we'll go back and pick those up and make that change. All right, so looking for the interference, if I go to Move Component, in Move Component you have collision detection, and if I just go to All Components, well, it's already going to start in collision because we have this thing going on where I missed the dimension or I have to check the dimension. So these components, I want to see where this hits this. And then when I resume drag, it's already in collision. So come back, it shows me where it hits. And it makes a little, I don't know if you can hear that on the speaker, it makes a little thunk, thunk, thunk. All right, so that's kind of handy to... So that's kind of handy to be able to see where that collision is occurring and make it resolve. All right, so let's go see what dimensions I reversed over here because I'm starting to think that I did. So there's the one with the layout, and so the little parallelogram there tells me I'm in the layout. And let's just go ahead and open that. I was going to do it at the top level, but layout front. So 2-inch 5.2, and no, I did miss it. It was 22510, 22515. So I missed the 2. That was where it came out as. And save. All right. So again, you see an obvious error. Hey, I got to go back and check that, find out what's going on. And now that looks a little tall because I was thinking this really needs to be flush. So somewhere else in the layout of this item, I have to go check that dimension. Or I picked the wrong thing out of the sketch. All right, so you get into these levels of complexity. I'm not going to chase every dimension to the nth detail. I got to move this along and figure it out as we get into the assemblies. All right, so we will take one more quick look at this before we get into, and there were the layouts, there was the front layout, and this went 5.5 from the top, and that 5.5 is in the wrong position. So it looks like it's going to the very top edge when it should have been the center, but that's really only good for 1 inch, but that might be the difference. All right, so let's go back into the front layout. I'll pick up that sketch. I'm trying to get a little better at dragging these dimensions, so if I reposition to the center, wow, there's the 4.5, so it was good for 1 inch. It updates. That's a little closer to that face. A little weirder, but on the fillets, so my weird fillets just got a little weirder. But now at least I've identified another potential error. I've taken a potential error and I've validated it and said, okay, this is what I need to update to. So that looks better. That comes up flush. All of a sudden my 30 degrees is not so much of an issue. I still don't know whether this is in backwards or forwards. We'll get that figured out eventually, hopefully. As far as clearances or what it would be doing back here, it doesn't look like anything's going to be in contact. Even if this could come all the way up, it's not going to rotate around. All right, and then we'll rebuild and go ahead and save. All right, so a couple things crossed off the list. Let's go ahead and we're still working on this side, so I haven't created the bushings, and there's going to be a bunch of little hardware. I do want to get into the drawings tonight a little bit, so we can carry those over. And so let's bring in the locator and the kind of the major components, and then we'll take one more pass after, well, probably Thursday night, and I'm sorry, after spring break, Tuesday after spring break, and be into the drawings and start talking about manufacturing processes and design for manufacturer. So, insert component existing, or thereabouts. We had that rough locator, and it goes into position. And I would really, that one's not going to be the best example, but we'll go ahead with it. So that goes into position, and it is going to be concentric. So it threw it out there in space somewhere, not too far for once. I did not catch the orientation, and so this is one of those where I would like to reverse it, but I don't really want to go into. So I right-click, I expand out, I right-click on it, and I can flip the alignment. Of course, then it throws it to the other side of the part, which is always fun. Like, why couldn't you just left it there? But it's in the correct orientation now, so we're better on that end. This is going to be in contact, edge no, face yes, coincident. And then we have to figure out rotation. All right, so as I come around, I should see that little fingernail. But the fingernail doesn't help me a lot. And we're still, until I have the connecting rod in here and see height-wise, the rough locator, how that's going to actually turn, kind of what the intent is. I know it's going to be somewhere along that line, and then we have one of the plungers or something in there holding it in place. All right, so the question is, do I leave it to where it can rotate and come back to it, or do I try to put it in position? I don't really have anything to that face that I can use. So really I'll probably end up being back over here, and just for convenience to the front plane, we'll go ahead and set it at an angle. And 60 degrees. See if that keeps it pretty close to the fingernail. Maybe off a little bit, depends on how far we rotate. But again, I pick those mates on convenience, not necessarily that I have a complete mechanical understanding of what the function of this part is. All right, so we've got that. Last time at the very end, I don't think that made it to the video, we went out to McMaster.com and we grabbed a couple of bearings. So insert components, and we drag down. There is my 6209 McMaster part number ball bearing. We got a sealed bearing, and as usual it comes in with a couple of sketches shown, so we just hide those sketches and those sketches and that sketch, and we're in good shape. So it doesn't have, I guess it has a little bit of the raised area, but really this relief on the interior is so that the floating part of the bearing is not going to be contacting the surface. All right, so I want contact to contact is going to be coincident. And so I'm showing the workflow that puts you into the fastest assembly process. All right, so going into coincident, and then control select the cylinders. So cylinder to cylinder goes concentric. Do I care that it can rotate? Probably not. I can just barely tell that it is rotating. It's not going to rotate in the in the function. So this is one of those. We expand out again, and we find that concentric, and then I say just go lock the rotation. I don't need it at a specific angle. I don't need it to be parallel at anything. I really don't care if the origins are turned on and the arrow's pointing out to the left. Just lock the rotation. All right, so it's not underdefined, or it's not under less mate references. but it just doesn't rotate anymore. So this would be one of my hardware pieces that I need, but I don't necessarily want it in this order. So one of the things when we create the bill of materials is the fasteners, the pins, the individual items. Those may end up in a folder at the bottom because we're not in any specific order. In a folder that says, this is all of my hardware items. All right. Let's see, when we did the assemblies, I don't think I've gotten to this one yet. We went through the 5 ways, 6 ways. Okay, now 6 ways. If I hold down the control button, I can bring in another instance by selecting from the feature tree or from the model. So if I was to control select this and just drag it, it would create a second instance of that part. So it's not a new part, it is an additional instance. And so instance 1 and instance 2 are the little brackets. Everything else is instance 1. We are incrementing those values, so if I deleted instance 2 and I brought in instance 3, it's not going to go back to instance 2. All right, and those numbers are pretty much irrelevant other than I'm kind of keeping track of how many instances over the life of this assembly I've managed to generate. All right, so face and control select the face, coincident, concentric, and we'll lock the rotation. I want to say inside of when we're doing the paperclip, so those pop-ups are going to be quite a bit faster than going into the mate list and picking those. But I believe when we assign concentric, it comes up with an additional lock rotation, and you can do it right from the mate. But expanding it out, identifying the concentric and saying lock rotation, not a bad thing. The other thing is within the mates, what I've done for fasteners is there's usually kind of an apparent break here where I know I've started to add fasteners, and socketed cap screws, hex bolts, things along that line. They're pretty apparent that I don't care about the rotation or whatever, so being able to go through and identify all of the concentrices, and this is a bad example of selection, but I can right-click on all of that group and say lock the rotation for all of my fasteners, for all of my bushings, or all of my whatevers. All right, so other than that, I don't go into the mates too much anymore. All right, so we got that far. We're ready for the cradle. And we said that the cradle would be a good candidate to generate a subassembly, not kind of come into the parts or into the top-level assembly and say after the fact, hey, it'd be great if this was a subassembly. Let's create one on the fly. So let's build a subassembly for the cradle. And I still have not created an assembly template that is residing in my folder, so I'm just jumping back to the standard templates or tutorials and dealing with that one. The open documents are the top-level assembly, so not a good selection. We will browse over to find the cradle. And then, let's see, we never did find in the database where we could put the threads on, and so we'll probably come back to this one after spring break and start with the swept cuts, and I'll see if I can find out the information on the thread tool. So again, going to the OK puts origin of the part to the origin of this assembly, and it fixes it. Well, all of the rotation is going to take place in the upper level assembly. Don't care about it here. So we're just going to go ahead with leaving that fixed in position, and the rest of the items tie into to it. All right, so the other item 6, cam. And let's fly this in for a second. We'll take a look at some of the build. So the cam goes in, and then the connecting rod top. And we can't really see what's going on there, but there are the 2 lock rings, retaining rings. And so item 6 that we had some fun with is going to be in that group. So I'll go ahead and bring that one in. There should be an additional shaft. Oh, before I fly that one out, then let's go to the earlier and see if we can decipher. So there's the cam. And then it comes back, we have the spring, there's that other little block with the angle, so we're good with that. I can't really tell which one that is. A little bit cleaner on the side. Alright, but no specific call out other than, hey, go find that part that kind of looks like that. And so that was, that's the other rough locator. Alright, so something else to look for. We'll find it eventually. Alright, so the spring, and then the item 6, and the other one. So component. And a lot of this, what you're seeing is habit of going to insert, connect, insert component. And so we bring in the cam. And we already have it in position, so that one can go concentric. And we know we have that kind of tight fit, or well, maybe interference fit at this stage. So I probably wouldn't go coincident because I'm going to have that gap. I could show it as coincident, but you know, probably pretty much not my preference. I would rather stay with the width so that when we're looking at the gap tolerances or trying to measure gap tolerances, because we stayed at maximum material condition, I'm already in the tolerance analysis. I'm already at minimal gap tolerances, and then I can relatively easily go back and calculate maximum gaps. Alright, so mate reference, we will go from standard mates to advanced, pick up the width. I could put this on the front plane, so since we drew these as mid-plane extrusions, I could go to the front plane. I kind of want to bring out the width a couple more times, so between that face, and then it self-centers. And if we go to the top view, then I can see there's a little bit of gap. So what happens is if I come back to simulate this item and put some loads on it, depending on the selections that I make for my example, for my simulation, those gap tolerances and the shaft and everything else, that stack up, comes down to some very specific settings in the simulation that we're defining. Question?
What's the width of the cam?
This was one of those weird 1.734 that worked out to 1764s or whatever. So yeah, that's a strange one. So it ends up that there's only you know, back to that half thousandths thing, you know, a couple of thousandths clearance. Okay, 10 thousandths of clearance. But in my assembly, since I haven't set any dimensions, that could be 5 thousandths or it could be 12 thousandths. It's not. I don't have 3 decimal places established. All right, one of the last parts that we did. Let's go ahead and save this. And we're just going to call that the cradle subassembly. All right, since it doesn't have a number or anything associated with it. And we'll browse. I can't remember what that thing was called, so we'll have to find it. And there's the other shaft, the other cam. Nope, nope. Nope, no, that one's buried. The rest button. Hey, that's probably it. That's what goes in there. Found it. And then our 2 round nuts, the clamp. That's what I'm looking for. Alright, so we'll go concentric. And then for comparison, we expect that to be 1.734. For comparison, let's do this one as a front plane. So I extruded this mid plane, and I should be able to go to the front plane of the assembly. I hesitate to go to the front plane of the cradle because I would like to have some error checking in that if the cradle was to move or to move off of center, that it would, wow, there's an interference there all of a sudden. What happened? And we can trace back through our strategy and you know, and follow that that decision process. So that can go to coincident. Maybe front plane of the part, front plane of the assembly, and that will also center it. But I have to make some of those decisions and otherwise know that they exist. Alright, so another advanced mate. And since this is not a complete surface, I'm going to be limited in what I can do for the cam, but we will see how far it goes. I should only need that surface. So, cam follower. Alright, so I'm not just going to jump into the cam follower and throw that one at you. We will go into the mates, and under the mechanical mates, we are going to be able to pick up for the cam, and we'll take a look at a little bit more what I thought there was more in the selections. Alright, the cam path, and then the follower. So it's pointing at the follower. And so in purple, the face, and then the cam path, yeah, that's the arc. So it's pretty much what I wanted. I thought there was some more that made me think of something else. So let's go ahead and have a radius less than that of the follower. Oh, it's not going to accept the flat. It wants that little bit of arc. This might have an issue, so let's see if it has an issue. Well, it follows it, and then it kind of reverses and does some weird things. So maybe I need a limit angle that I'm only going to throw this 30 degrees. I could do that, and then I'm not going to run into the weird interferences, but I have most of it there. I get the general sense of what it's supposed to be doing, so not that big of a deal. What's the other shaft that goes in there? Or is that was just a pin? I think those were just pins. Let's see if I can find that one real quick. Yeah, 625 by 3.5 inch pin. Alright, we'll worry about those later when we get to the bushing bearing side. Alright, so cam, the clamp, insert components. We'll browse back over to the, whatever I said that thing was, the rest button. And maybe the rest button, let me go ahead and kick that one out and make sure to save this, rebuild and save. And I don't want to let this go too long before we do the mate references. So I'm going to pick an edge, and then the rest button is kind of a candidate of maybe we use this more than just in this assembly. And so if I add a mate reference and I'm going to put this in multiple locations within my assembly, having the mate reference is an advantage because we're going to pick that edge, and then I'll go ahead and save it, and it adds a reference, default reference. And there's some rules of naming if you want to have more than one mate reference, and then it gets confusing, and about that time I just kind of go, okay, I can use one mate reference, cool, next. And so I never quite make it to the second and third mate references. I'm going to get a lot of value out of just this one, so I don't worry about the others. So if anybody figures it out, let me know. Alright, so rest button comes in, and now, instead of floating around in space, it says, oh, you have a cylinder. That cylinder is automatically going to get a concentric. Those faces are automatically going to get a coincident. And so I click, and I'm done. Alright, so that one little mate reference saved me a couple steps. Alright, so let's see if the length came out okay. And so this one, as far as the rotation, oh yeah, we were going to determine if that could have the angle so that we could improve the manufacturing process rather than having that back angle and custom grinded tool. Okay. So that being the case, let's see where that lands. Front plane, top plane works. And then the right plane of the assembly, I'm good with that. I'll just jump into the mate, apply a parallel. All right, it used to be that the default was coincident, but the problem with coincident is there's an 1.5 inch gap there. So coincident hardly ever worked unless they were already aligned. And so either 2015, 2014, 2015, somewhere in there, they said, okay, if you have two planes that aren't already coincident, it's going to default back to parallel and not bark at you every time you do that. So that was kind of nice. All right, so hopefully that's the rest button and where it belongs. So then the question on the lock rings, when we put those in position, I don't want to create an interference by going right to that edge and saying that's my edge. So we're going to do one more save and come back to the upper level assembly. And really they're going to be sitting between face to face. So at least in the semi-perfect world of my model, that's going to give me a normal distance of 4.25. If it works out that in the cradle, that distance ends up being 4.25, 4.17. Or that distance ends up being 4.25, 4.3. All right, I'm going to be setting a distance mate for that item. All right, so let's go ahead and bring in the rings. And we have the round nut, and then we have the one that has the bearing face on it. So I'm assuming that is to the interior. So without the mate reference, we're going to go concentric. And I don't like its position, so we're going to expand out. While it's here, flip the mate alignment, and sure, I'll lock the rotation because I don't really care. And we're going to come back to that face, and I'm going to give it a distance, 4.25. All right. So when I bring this into the assembly, into the upper level assembly, I'm kind of looking at as, again, when I put this on the face, that there really shouldn't be a gap here. And we haven't established preload for the bearings or done anything crazy that way. So it's just basically, I'm not at an interference, and I have a measured distance that I'm working from. And then we'll go to the next item, item 12. Or item 13, and we go concentric, and shouldn't really matter, chamfers on both sides, pretty much symmetrical, coincident, and then probably aren't ever going to line up with anything anyway, so wherever I lock the rotation, concentric, and lock rotation, I'm going to be okay with that, and save it. Alright, so except for hardware, the plunger, push the pin, spring, pins, we have pretty much what we need. Maybe not the angle just yet. Alright, so back to the top level assembly, have the selection, and we're going to insert, and we go to the cradle, and we drop the cradle in place. Sort of. Alright, we get it close, and then it really doesn't matter. I could go to the bearings, I could go to the center, and go concentric, and then we have that bearing face to the cradle face, and then what does my rotation look like? Alright, we know it can move. How much can it move? Alright, at that point, we could have put a little bit more so it could do that, but then that kind of defeats the purpose of having that over there. So I would like to know what that angle is. And that still doesn't tell me what this is doing as far as the relief, but we have enough to go on. Alright, so I'm going to try the move component, collision detection, these components from this face to this face. Go ahead and stop at the collision. Oops, I didn't want to do that. Let's try that one more time. Move, collision detection, these components. Oh, they were still selected. And stop at collision, resume drag, and I contact it. Highlights in blue, it's in contact. So I can go to the planes, or I can just go to the face and say 167 degrees. 90 minus 167 degrees is about 23 degrees. Do I want to go try the plus minus? Sure. We're going to set a limit angle on this of about 23, 22 and a half degrees would be nominal. I'm okay with the 23 degrees. Make sure this saves. And so the front plane of the cradle to the front plane of the assembly. And we're going to go into the main. We're going to set this as an advanced mate and a limit angle. So 23 would be, that's its current position. Actually, you need the current position at 0. Minus 23 degrees and minus 23 degrees. All right, so I didn't like the maximum value being a minus sign. So maybe that was the previous issues. We'll go ahead and accept. And that one didn't quite end up being 23 degrees, did it? So 167, 90 minus 60. Oh, 167. All right, so 180 minus 67. That comes out to 13 degrees. So don't trust me when I do math in my head. Get out your cell phones like everybody. No. All right, but an easy fix, we go back in, we identify the items, delete, and OK. All right, so contact, that's the range of motion. We have enough relief back there that it looks like it might be contacting on the radius just a little bit before. Oh, whatever. I'm not overly concerned with the radius. All right, but we have a really good start. We made some corrections, and let's take a quick look at the drawings then. All right, so I'm not far enough along to create an exploded view, so I'm not concerned with the assembly drawing so much. Let's bring in one item. We'll go for the body. And we'll look at some of the things that we can do with this body part, or O1 body. All right. So when I go into the new, I haven't created a drawing template as of yet either. And going back and reviewing what I've done previously with the drawings, when we make the drawing template, I will probably revert back to take your favorite existing ANSI or ISO layout. Sheet format and modify it. What I got into trouble with was because I wanted to create my own from scratch, brand new. And whenever that happens, we all know that that's is not going to end well. All right, so at least for this one, I don't want to get into the templates. I don't want to get into the annotations. We're just looking at the body, and I can always come back later and update my sheet format. So with one of these days, I need to do the conversion and say that we are 11 inches, okay, and 8.5 inches. Is that doesn't sound like 279 though? So anyway, we have the size. I'm going to browse, and we're going to just bring in the body. All right, so by default, the model view is where we start with a standard drawing view. And then we have to decide, are there any configurations? Well, I have that as cast configuration. Well, for the default, my first look at it, we'll go with the default. And yes, I want to create multiple views. Probably not enough room based on the length to shove an isometric in here. So maybe we do that one separately. There's probably not enough room to put 3 views either, but we'll see what happens. All right, and then the display states, as cast layout, how much of it do we want to see? And then what is the display style? At least initially, I like the hidden lines removed. If it doesn't add value and it's going to make this more confusing, I would rather go without the hidden lines. All right, but probably for this one, let's see what it looks like, hidden lines visible. sheet scale, it does an automatic calculation. It says, it looks like about 1 to 5. Since it's probably pulling from an ISO reference, we would be 1 to 1, 1 to 2, 1 to 5, 1 to 10, as opposed to quarter scales or eighth scales. All right, and then projected, true, high quality, and draft are all okay. We hit OK, and it goes out and it says, I am now referencing your part. Here's what you see. And there's all your information. All right, if I do not have O1 body, then all of these turn to nice little amber boxes, and with X's through them that say, can't find the part, you don't get the view. All right, so they have to travel together. As far as moving things around, the front view is the parent view, or the primary view. So the alignment says that the top view will be able to move up and down. The right view will be able to move left and right. But everything moves in reference to the front. All right, I can break that alignment. Probably don't want to do it right now. And if I added an additional view, then I could also go back in and add alignment. All right, so that gives me a good place to start. We have not created any layers. We have not created any additional options. We're all at the defaults. So this just gives me a starting point to discuss the views and putting in dimensions, creating additional views. All right, so the additional view that I might like to see, everybody likes section views and detail views. So under View Layout, if I create a section view and I want to see right down the middle, well, it gives me the nice little pattern, but I really want it to be the other way. And I would like for it to be attached to something that's probably not going to move. And no, we're not doing an arc offset or a jog single offset or some weird, go through 3 different levels offset. So I'm just going to go ahead and accept and pull off the section view. All right, and up in the options are the standard fonts for the section view, and that large section, small AA kind of drives me crazy, but we'll worry about that one later. All right. So downside is that that's not really the direction of the section view if I'm folding this up like a standard view. It's visible, but it's a little strange. All right, so it gets alignment as well. And so that might be something that I would want to put on a separate page. And so I think I can, let's just break the alignment. So right-clicking on the view, going to its alignment, I can break the alignment, and then this can move freely and do whatever I want it to do. I can also hit the Control-X, yes, delete, and come down and add a sheet, and on the second sheet, paste it in. All right, so section AA, reference, reference page 2, whatever. All right, detail view. Let's find an interesting detail. Of course, this was all interesting. So the detail view then is going to ask us to draw the circle, get something started, and it's also a sketch circle, so it's going to have some geometry attached to it. All right, so detail B, because my section view is A, we start with A, whatever the next view is B, next view is C, it's going to go through those items. So 2 to 5, okay, so 2.5 times, that's a lovely lovely view. We can live with that. All right. Before we get into the dimensions and just putting some basic or getting into some of the detailing, let's add one more sheet, and we'll do this again from the view palette. And on the view palette, a lot of companies are moving more towards the view palette rather than the model view. I go back and forth, and I whichever one's active, I'm good with. I don't care one way or the other. So we had the cradle, the full. So these are assembly drawings. I need to browse. So the ... We're going to go back and pick up the body again. And this is going to go with the front auto start projected view is nice. So instead of telling it I want 3 views, I'm going to bring in the front view. We'll drag a view off and go ahead and select. And isometric is isometric. All right, so the thing that comes up every once in a while is what we're looking at, what happens when you have something that is a first angle projection. And really it's, to me, the way I describe it is how you are manipulating the part. And so when we pick up a part in third angle projection, I hold it in my hand and I rotate the part, what would that be, clockwise. I'm now looking at the left side. This is my left side view. However, if I go to first angle, it's actually looking at it this way, which means that I'm going clockwise. I set the part on the table and I'm going clockwise around the part. And so when I go this way, my right side view is actually looking at it this way. Confused yet? That's why none of us can manage first angle projection. So when you get first angle projection, the thing of note is that very quickly the isometric is in the wrong location. All right, is in the lower left, wrong or right's not an issue to discuss. Left view, front view, and top views all go accordingly. All right, so if I want to add a view, let's just go with the projected view, and I drag this down. Notice that that's the view that I got, and the bottom view is in relation to the part. I can't say that I've ever encountered more than examples of first angle projection, but there are a handful of countries that still use it or use it, prefer it, and you have to be prepared for it. All right, so we've mentioned it, you've seen it, let's move on. Annotations. All right, so smart dimensions. If I go just like we did in the sketch, I'm going to be able to pick edge to edge, or I would be able to pick an entire object, so an edge, and get the same thing. Let's see if we go to center lines. All right, so in my settings, in my options, which is a whole nother conversation, I have center marks set to come in automatically. So that's why I got a center mark. Did not get center, the center marks. All right, didn't get them on all of them, but I got quite a few of them. So overall, and then we can start to apply those dimensions. Well, usually we want to put some colors to those, maybe change the font, but for starters, we're going to just apply a few dimensions and get this going. So things like center lines. One of the dimensions that they had was from this bore to this vertical bore was a dimension. So I needed a center line that I can pick from there to there. And it shows up in the basic format, but it is an actual center line, and I can now dimension to it. So center line to center mark, and when I'm picking the center marks, I'm going to make sure that I'm on a vertical or a horizontal, because that's going to drive, help drive the dimension. So 3.5 inches, and we have those locations. Diametral and radial. So when we pick, just like the smart dimensions out of the sketch, notice I'm in 2 decimal places, and continuing that my default was an isometric, or not an isometric, an ISO-based template. I'm not looking at ISO or ANSI dimensions. I got ISO on them, right? All right, so my ANSI dimensions would have the little leader and jog line and everything else. And the 8.8, instead of being vertical, would be horizontal between the extension lines, not on top of the extension line. So I think I've mentioned before that 2010 or 2011, I loaded up SolidWorks. I didn't think to switch it over to ANSI. I started using ISO, and I found some very distinct advantage to having these dimensions be vertical on top of the extension line. So love it or hate it, I started using it, and since I found those advantages, I kept using it. All right, so I don't care which one you use when you're going through for track 1 for the chapter 4 assignment. Whichever one you pick, whichever one you prefer, knock yourselves out. All right, so our circle is automatically going to go to a diameter, and then a radius or an arc is automatically going to go to a radius. Just like in the sketches, we're going to be able to switch those from the leaders to a radius, back to a diameter, to a linear, and then there's also a one arrow solid leader, goes through the center, and one arrow open leader. And then some of these have, maybe not this one. I was going to say if it gets really long, it has the break where you can do the jog length or really large diameter, those types of things. Most of that is going to come up under the leader. Not really the break lines. Maybe it's the break lines. Oh well. I'm guessing again, and we're getting close to time. So documents, and then we come over to the layer. So when we get further into the drawings, we'll set the layers because I would like to have a little contrast, make this look nice. My center lines could be in, I usually pick magenta because they jump out at you, and it annoys everybody. Dimensions are in blue, nice calming blue. And then what else? That's about the extent of my layers. I maybe generate 4 layers, and what else do I need? Right, so we'll go through some of the details then. All right, so a few dimensions. All of the rest of this we will get to. All right, so notes are our annotations. The note patterns, balloons in the usually with the assembly or exploded views, magnet lines are all related to the views. Surface finishes, I think we have a few of those. I pretty much decided that we're not going to go through and put grind marks and surface finishes on every single thing that they ground here. I don't know that we could complete that this semester. It would be close, but on the other side is it's not supposed to be any more miserable than I've already made it for you. But we will take one of these and go through that as cast. This is what I need to build the part. This is what I need to manufacture the part. And then in the normal manufacturing process, these are the stock that you're going to leave so that I can come back and perform those finishing operations of grinding or EDMing or whatever it is that we're going to do. Hole callouts, we have a couple of those, so let's do a hole callout. And when I pick on a hole, it will, and it's not in the correct place because we updated from 2015 or 2016 to 2017. So I have to go find this file for the callout format and make sure that it is correct. But it should be counting that there are 4 of those. Usually I would get 4. And we would see the spot face, the through hole, 0.05 or 0.53, 1.5 inches through. Well, that's the length, so depending on... No, we did not give it a through all because this was the legacy. Use the legacy to create the spot face, so it's just seeing that as a depth. So I'm okay with the 1.5 inches. That's a little bit strange, but I would rather see it say through, but whatever. And then the spot face, 1.25 inches, 1/8 of an inch deep. So it'll do instance counts. It'll do a little of the other information. And I just noticed that my B got stuck in the middle, so we'll kind of drag that out and clean that up a little bit. So things like details may get a different color so that we can identify and help to pull those items. All right, there was something on the section view. Oh, scale-wise, this is going to be pretty small on an A-size sheet. So scale, we can go back into the properties. And another quick note is if properties does not show up on yours, that you will expand out, customize the menu. And I believe I've already done this, or I don't typically delete views on the right mouse button. If you do, go ahead and keep the delete on. But make sure that the properties are selected, are checked, and then it will show up. Otherwise, we got to go find it somewhere, and I usually just want to go Properties, and there is the sheet scale. So if I went half, not going to fit, but it'll look cool. So missed it by that much. So if I wanted something that was by a third, we are not locked into having to have scales, specific scales. If I want to make 84/89 my scale, it'll figure it out. We do the math. If that's what it works out to, great. It's kind of an oddball scale, but hey. All right, so we get the section view, we get it scaled to the drawing, and then now that we're in section view, we can start to pull out some of these other items. All right, so if I'm not on this end view, I should be able to go between those. And even though we're in that section view and it's through the cutting plane, it's still going to show up as a diameter because I'm dimensioning off the cylinder. If I don't, I'm more concerned if I don't see that diameter than I do seeing that diameter. And then things like the depth, 0.75, to the spot face, 0.81. And we'll talk about the precision, the number of decimal places, all that kind of stuff later on. And then I don't know if it'll show up. Let's try it. Probably not going to pick it out. Nope, doesn't like that one. I was hoping to find one with the hole wizard, so yeah, that's a good example. So hole call out, make sure that's selected 3 times. So it does find the instance count from the hole wizard. It has the diameter 0.26, pretty close, 7/9 deep, 5/16 18, and gives us the full call out. So yeah, surface finish, weld symbols, hole callouts, GD&T, datum features, datum targets, and blocks. All right, so blocks are pretty much like blocks in AutoCAD, where I want to create something and treat it as a grouping or as a symbol. I can create it as a block. There are times where the blocks can't be found or resolved, and so blocks I haven't used as much as I probably should have. The center marks we've got in place, but they're all on the standard format. Center line we created. An area, hatch, or fill. Let's see, did this one section? So all of this is based on the ductile cast iron that we selected, and that is the section view or the hatch for the section view. Came in automatically from the material, not anything that I had to add. But if there was an area of interest, hey, we're going to texture this, or this area gets that I'm going to put green Loctite on that for bearing retention or lubrication, or whatever. I can identify that area and say this whole area needs to be coated as part of my assembly process, and make notes as we go through with the area and hatches filled as a call out. Revision symbols and revision clouds as we go through the design process and more people are involved and look at this drawing. The revision cloud says, hey, this isn't deep enough, or no, let's put 4 holes here, not 3, and we can see that cloud, and it's something that can either be printed or not printed with the drawing. And then we go over to the tables. We can manually enter data into a table. The whole table would be all of the positions. The bill of materials for an assembly, everything that we've included in the assembly. The revision table, what has changed, what has been updated. Weld tables, typically, is it a stitch weld, is it an 1/8 inch stitch weld, is it a continuous weld? We were talking about sheet metal earlier with the bin table, and where are all of the bins, and how are they identified in the drawing if it gets fairly complex. And then the punch table, if we are pulling in items from the design library, like the punch countersunk or retention, then where are those locations and what tool is being used to create it. Views that we didn't get into, we did a little bit with the projected view. Auxiliary view, I want to come off of this face and look at it normal to that face. We did the section view and detail view. Those are going to be the most common. Broken out section I want to remove back to, well, let's go back to this one. I want to remove this back to some depth and be able to locate it. And then the break view, well, this thing's really long and there's nothing going on here, so let's take out 5 inches of the middle section and shorten this up so that I can see more on the page. And then crop view, I want to call attention to just this detail, and rather than creating a detail, I want to just chop it out. And then what's the other one? Or maybe I got that backwards. No, I think I got that backwards. So check that. Existing view, show only a portion. Yeah, it's gonna take out just that view. So which one? Oh yeah, the broken out section is going to take it to a depth. And then alternate position, we have all those cams and things that are moving. I want to show them at their limit dimensions. The alternate position view will either create the configuration for me or use an existing configuration that is at the max or min value, and it will put the dashed lines at the max and show it at the at the min in the drawing. All right, so we have a lot of functionality that we're just barely going to scratch the surface of, but we're going to take it a little farther than we